Hello, everybody. This is Brian. Thank you all for joining us. We are here doing a seminar, and we're excited all of you can join us. We're going to hang out just a little bit, maybe wait for some last-minute stragglers who might be rushing from whatever they're doing, probably finishing their dinner to get to the internet and watch us stream live. So my name is Brian Fountain, and I'm the Chief Creative Officer, and we'll get started in just 1 minute, and then you can be here to join us. All right, so hopefully everybody that wants to join us is here, and if things become too confusing as we move forward, we can jump in the chat room, and hopefully Maddie's here to answer some of your questions. All right, so would like to go ahead and get started and jump into our presentation. So let's see here. All right, so we've got, let's see, our seminar topic is Demystifying Programming. I'm here with you. My name is Brian Fountain. I am the Chief Creative Officer at New York Code and Design Academy. I'll tell you a little bit more about what we do at the end of the webinar. But thank you for joining us. We're really excited to have you and to answer a few of your questions. So let's get started. We are assuming that you don't know anything about programming. So we want to start really at the basics about what it is that we're trying to do here and to explain. So the first question, what is programming? Well, in its most simplest format, a program is really just a set of instructions. That is a series of steps that have been defined ahead of time to achieve a desired outcome. So it's a lot like a recipe. Now, one of the interesting things about a recipe is all of you understand the format of a recipe and how it works. But computers are different. They need instructions in a very specific format, all right? So programming is the act of writing out those instructions in that specific format that a computer is expecting them. So here's an example of programming. A programmer is going to the grocery store and his wife says, buy a gallon of milk, and if there are eggs, buy a dozen. So he goes out, goes and does the shopping. When he comes back, his wife says, why did you get 13 gallons of milk? And the programmer says, because there were eggs. Now, this might make sense to you and you might laugh or you might be confused. So let's take a look at what does that actually mean? Why is that funny? Well, this is the way a programmer thinks. So the instruction was buy a gallon of milk, and if there are eggs, buy a dozen. Well, if we looked at this in code, it might look a little something like this. Buy milk, size gallon, quantity 1. Then, if there are also eggs, then buy milk, size gallon, quantity 12. So we have a total of 13 gallons. Now, you obviously know that's not what was intended, but computers don't know. So the discipline of being a developer is understanding the way computers want to be talked to and how to actually write those programs. Now, what can a programmer build? There's a whole bunch of things. So one of the things that you might know are computer programs, things like Microsoft Word or the other applications that you use on your desktop PC. But then there's also things like mobile apps like Candy Crush or Flappy Bird. There's operating systems. I'm using a Mac, and so it has Mac OS X, but there's also Windows. And then things that you might not be aware of, but programmers work on too, are things like embedded systems. So this is like the software that powers your car. That's right. There's software under the hood that's making determinations about things like emissions or how to rev up the engine in an efficient way. And then, of course, there are websites. And examples of websites are things like Facebook, but we've all used websites. And all of these need programmers to build. Now, we could talk about all of these, but I want to focus on one particular topic, and that's web development, okay? So web development is what we call the process of making websites. So web developers are the programmers that create websites, and sometimes they're referred to as web applications. Before we get too deep into this, let's just talk briefly about how the internet works. Most of you have a high level understanding. I'm sure that you're comfortable using the internet because you're watching this streaming video. So you know a little bit about it, but let's break it down, some of the stuff that's going on in the background that you might not be aware of. First off, there's something that's called the client-server relationship, okay? So what's a client and what's the server and how do they know each other? Well, the client is not this particular woman, but in fact, the computer that she's using. That computer has a browser on it, a web browser that goes out and connects to the internet. And it goes over the internet and eventually reaches a server. And this server formulates a response and returns it back over the internet. So we call this the request response cycle in web development. That is to say, a client connects with a server over the internet and you get a web page. So you type in your browser, www.google.com, it goes over to one of Google's servers, they return a web page, and now you see it on your browser. So how does this work? Well, first off, we have to write code to do all of this stuff and to make it work. And in this, we have this idea of the front end and the back end. You may have heard the phrase a front end developer or a back end developer and not know what those meant. So let's talk about that. Well, remember how we said we had a client and a server? Well, the client part, that is the browser, and now a browser can be on your laptop or it can be on your mobile phone. There's a lot of different ways that we can use browsers, and eventually probably ones on your watch as well. Well, the browser part is the front end. That's the client, okay? And there's three particular technologies that we use when we discuss the front end. So those are HTML, CSS, and JavaScript. Now the back end, the server that it connected to, it can use a whole bunch of different languages. So examples could be Java, JavaScript, PHP, Python, Ruby, others, okay? So that's a lot of options. So front end, back end, HTML, CSS, JavaScript, Java, JavaScript, PHP, Python, Ruby, and others. So wow, this is already extremely confusing. Okay, well let's break this down a little bit. First off, these HTML, CSS, and JavaScript, they're not so crazy complicated. HTML and CSS you can learn in half a day. JavaScript takes a little bit longer, but you don't absolutely need JavaScript to build web pages and make them work. Now, the backend, what's with all of these languages? Why so many? Well, it turns out that you can use a bunch of different choices for the languages that you want to use on the backend. So really, you only need to learn one of these, and you will be good to go for building full stack, that is front end and back end websites. Okay, so that's just a quick dip into some of the technologies. What I want to do next is I want to focus on the three technologies involved with the front end and one of the technologies associated with the back end. So just grab one of those examples. Before we do that, I want to talk a little bit about static versus dynamic web pages. Some of you out there, you might realize, wait a minute, I've made a web page before and I didn't have to use a back-end server to do it. I coded it up following a tutorial, and that's absolutely true. It's possible to create web pages using only HTML and CSS. You don't even technically need JavaScript to make a functioning web page. You can just use HTML and CSS. So why do I need to know all that other stuff? Well, it is possible to create a static web page. That is a web page that doesn't change and put it up on the internet and serve a website. That's absolutely possible. But when people think about modern websites, they often think about dynamically built web pages. What's an example of that? Well, Facebook or Twitter or even Google. These are all pages that are assembled at the time of the request. So remember that request response cycle? Well, that request response cycle is letting you know, hey, a request comes in, show me my page, and what's happening is the server is building it dynamically on the back end. And so it's these dynamic web pages that are the difficult thing to learn and that a lot of people invest time in trying to get great at. The HTML and the CSS is not too complicated. So I actually just want to show you some example of what this stuff looks like, all right? So don't forget, in the front end, we've got HTML. That's for content markup, and I'm going to show you that in just a minute. CSS, that's for layout and styling, and we'll see what that means. JavaScript, client-side behavior, and then the back end, we have frameworks, things like Sinatra and Ruby on Rails. Now, we're not going to go too deeply into the back end. We're just going to focus a little bit on HTML, CSS, and JavaScript. But I want to show you some examples of what that technology might be. So first off, let me just code up a simple web page here for you. I'm going to show you what it looks like, and then you can see how the technologies work together to create a web page. So first off, I declare a doc type HTML. That just lets the browser know what type of HTML this is. And then we have an HTML tag, a head tag. This describes the parts of the page that the user doesn't see. So it kind of gives you some information about that page. And then we've got a body. And then I'm writing up a header 1 and then a paragraph and some content inside of it. And then I'm closing off the body and I'm closing off the HTML. Now that's a fully functioning web page. Okay, so that's an example of something you could type up in 3 or 4 minutes and have a fully functioning site. So let's just break this down, what it is that we're looking at. So first off, I mentioned HTML. So what is HTML? Well, it stands for Hypertext Markup Language, and it contains these tags and regular text that are contained within those tags. Why do we need it? Well, okay, so bear with me for a second. We say that it marks up the text semantically. Okay, semantically just means the meaning or the purpose of this particular information. So in a page, we describe what these sections do. If we think about it as a newspaper, for example, we have a headline, and then we have a body, and perhaps we have a byline that references who actually wrote the article. So we in HTML would wrap this content up with these descriptors, like this is the head section, this is the body section, this is a header or a title or a paragraph. And so we mark up all of the content so that the browser knows what to do with it. All right, so here's a simple example of an HTML tag. It's the title tag. So we open it like this, we put our content in the middle, and we close it with a closing tag. All right, that's a really simple. So if we look at this again, we can start to see that we have this basically this declaration at the top that says we're using HTML, but then we have a series of opening and closing tags that contain all of our information. And that's HTML. It demarcates the pieces of our page. So now CSS. What's going on with CSS? Well, this is how we style our page. So CSS stands for Cascading Style Sheets, and it dictates the coloring, layout, and simple animations on the page. It allows us for fine-tuned color and positioning control. So what I want to show you here really quickly is I'm going to go over to my browser here. I'm going to go to a text editor here, and I've got an index page. And right here, I've got a really simple web page, and I'm going to say hello from NYCDA. And I'm going to right-click this here, and I'm going to open this in a browser. And we can see here a really simple web page. Now, what I'm going to do next is I'm going to go over to my CSS page, and I'm going to say that the body color should be blue. Okay, so I'm going to save this and then open it up in the browser, and you'll see here all of the body colors are blue. Now we can see that this text has gone to blue. All right, so that allows me to style the color of all the elements inside of the body. So that's CSS, and it follows this particular format up here. And I won't go into too much detail, but that's the basics of why we use it. And so we can use CSS to style our page. We can do a lot of things with it. We can say that that links should be underlined and that they should be purple, or that paragraphs or headers should be, for example, in a different font. And I can even do that in line right here. I can say style equals, and then I can say font, let's see, family is, let's make this Arial. I'll hit save on this, I'll hit refresh, And now we'll see that this particular piece of text is in a different font, okay? So that's just one example of styling. All right, so back to our presentation. So here's a simple web page and how it looks with a little bit of styling placed in there. Here I've said that the paragraph should be color blue, and we get that, okay? Next, I want to talk about JavaScript. So JavaScript, it controls all the interactions that make up the website. And so when we think about HTML and we think about CSS, they're not really scripting languages. That means you can't write a program in HTML and CSS. You can make some web pages, but you can't do a lot of functionality. So for example, if you said, I want to make a game of tic-tac-toe, I couldn't do that with HTML and CSS alone. I would need something like JavaScript. And it allows me to write code and have it be performed inside of the browser. And it allows us to make logical decisions about what to do based on the user interaction. So let's just see a really quick example of that. So notice here on the H1, I've added this onClick equals alert hi. Okay, so let's take a look at how that might actually work inside of our browser. So I'm going to go back to my text editor here, and I've got a little prepared web page that has this code inside of it. And so I'm going to click here, and I'm going to open this in the browser, and I'm going to click on this, and you'll see here it pops up and says hi. So that's exactly what that code does. All right. So on click, when somebody clicks this particular element on the page, pop up with an alert that says hi. And if I want, I can just say, hello from New York Code and Design Academy. So I'll hit save. I'll open this in the browser again if I want. And I'll click here, and you'll see that the message has changed. Hello from nycda.com. So we can make these changes and see the effect in the browser immediately. All right. So that's a real simple web page now with some JavaScript. That is the front end. Those are the three technologies that you need to build a web page. Now let's talk about the back end. This is for dynamic web pages. So Ruby is one example of a language that you can use to build websites. Now Ruby on Rails is one of the things that's a web framework that you can use to actually take that language and build websites quickly. And so you'll often hear that phrase, Ruby on Rails. And what that means is it's a particular framework, Rails, built on the Ruby language that allows you to make websites. Okay, so Ruby is a full-fledged language like JavaScript, and it processes data, sends it to the right place. It can return the data that you need, interact with the database, identify and log in users. Other languages that do this include PHP, Python, and Java. Okay, so there's a lot that you can learn about Ruby, but what it does is it allows you to store things in a database or dynamically create a page in the same way that Facebook or Twitter does or Google. All right, so that's just a really quick introduction to the Ruby programming language. You might want to know more. There's so much more you can learn. So we're going to give you a couple resources here of how you might be able to do that. So first off, you can learn online using Team Treehouse or Code Academy or W3 Schools and Stack Overflow. Now, Team Treehouse has some guided practice as well as Code Academy. And W3 Schools and Stack Overflow are a little bit different as resources. So W3, the way it works is that you can basically read the documentation, and there's some light tutorials. And then Stack Overflow is a resource that a lot of developers use when they're just trying to get answers to questions. So often you can go on there and ask questions that you may have, and you'll see them answered. But more than likely, when you're Googling for an answer, you'll find it there online. All right, there's also hybrid learning models. So Thinkful, Code Mentor, Hack Hands, online. So these are some options where you can not only learn online, but you can work with a human being to help you learn. So often when you're learning these things, you run into some brick walls and it's kind of difficult. So it's often good to have a human. And if you really, really like human interaction, if you've tried learning online by yourself and you've hit a brick wall, there's always in-person instruction. And of course, I'd love to recommend the New York Code and Design Academy. We currently have locations in New York, Philadelphia, Miami, and Amsterdam. We have new locations coming all the time. If you'd like more details about that, you can, of course, check out nycda.com. And that's it. That's it. We're just talking about demystifying programming. Hopefully that's answered some of your questions. I was so excited to be able to share some of this information with you tonight. If you have questions, please let me know, and I'll be happy to answer them. And my email is brian@nycba.com, and you are good to go. All right, thanks. Join us next time.